Hello.
Hello, sir. Assalamu alaikum.
I'm I'm sorry, actually, the
It's
meeting
okay,
was
sir. No
long.
problem.
Okay, it was a long meeting, selection committee meeting. Okay. Okay, in our today's lecture, I want to start the statistics part of data science. In statistics part of the data science, it is also essential because we know that data can be textual form, data can be numeric form, or data can be like images or signals. Various forms of data usually we need to process, but before going to process those data or analyze those data, we have to prepare the data. And for data preparation, we need to apply some form of statistics for pre-processing, for standardization, for scaling, for normalization, and also from some data we have to take the decision. Usually we call those the hypothesis testing. Okay, there are several methods of hypothesis testing also, and maybe in next two class we also discuss about those hypothesis testing methods. So first, the inferential statistics. The statistical approaches usually we divide into two types. One is called the descriptive statistics, and another one is called inferential statistics. In descriptive statistics, from the data we have to find out maybe the mean, standard deviations, skewness, or we can present those results in chart or graph forms. Those are also very necessary because from the data sometimes we need to extract features, and the statistical features is one kind of feature extraction methods. So statistical features like the mean value, the standard deviation, the skewness. Okay, so those are our descriptive statistics. So I think the descriptive statistics we also discussed in our there is principal component analysis. In principal component analysis, before discussing the principal component, I discussed few the basic statistics. Okay, over there I think we know how to descriptive statistics. And now from this lecture we want to focus on inferential statistics. Inferential statistics basically used for inferences, or we can say predictions from the data, and there are several other things also. So using the inferential statistics, uh, instead of just go through the population from the sample, we can make the conclusion, or we can say generalization. Maybe we can say that it is very hard or tough to maybe collect the population data from the whole population, but we can take the sample, and the collected sample, it must be actually we need to follow some statistical method, that is how many samples are required for that. The statistical evidence we need to have for the samples also. For example, uh, you might stand in a mall and then ask a sample of 100 people if they like shopping at YOLO or not. So some of the people, they will say yes and some will say no. And from the yes and no, maybe you can find out the average number of people said yes and find out the average number of people said no. So those kind of things. Those are the descriptive statistics. But if you want to claim that around 70 to 80% of the population like shopping at YOLO, so this is a claim. This is an hypothesis. Okay, this is a hypothesis. So for that to say like this, we have to prove that hypothesis. We have to test the hypothesis to conclude the statement. Okay, the statement like this. So that means we need the statistical inferential statistics for that. So usually in inferential statistics, majorly what we do, we collect the sample, and then from the sample, whatever we derive, that is whatever we conclude, that usually we generalize to our population. So in fact, the statistics, this is the primary job or primary task. So that means we need to find out somehow, we need to find out the relationship among the samples and the population. So we will learn the methods, several methods for that. But before going to discuss about the inferential statistics, some of the concepts we need to understand. The first concept is data distribution. Okay? The data distribution, usually if we have the data, and then maybe from the data, if we do some form of frequency distribution and plot those frequency distribution, then you will find that there is this kind of maybe graph, this kind of plots. So in this plot, we can see that most of the data we will get in this slot, in this, that is the bin, and we can see that actually in left side it is spread out. So this distribution we can say that it is spread on the left. If we get the data and also we can see that is we get this type of distribution, then we can see that that is this data is spread on right. And sometimes maybe we will not get any kind of distribution. It kind of jumble up, or we can say kind of zigzag patterns. And sometimes we will get maybe nearly Gaussian distribution or bell curve. So there are several types of data distribution. We have like the Gaussian distribution, binomial distribution, and Bernoulli distribution, and gamma distribution, and uh, here is the normal distribution. Okay? But majorly, we assume that our data is distributed in normal distribution. So this is most of the cases our assumption. We assume that our data is distributed using the normal distribution or following the normal distribution. This is assumption. Most of the cases we assume this one. Though maybe this is not 100% true, but the assumption is this. Okay, most of the cases we assume like this, and also this assumption provide us the better insight of the data. So that's why the assumption, most of the case, we assume this. So in normal distribution, the density function, or you can say probability density function, we call it PDF. It is a continuous probability distribution. Okay, so we will get the continuous probability distribution. And here, this is the equation usually we follow to find out the probability of a data like X. So here we can see that there is f of X if we can provide the mean of our data, and here is the variance of our data. So from the data we can easily calculate the mean and variance. If we provide the mean and variance, then for any given data like X, we can find out the distribution. There is the probability of that. So this equation, I think you have seen many times. Specifically this equation for Gaussian distribution, it is used in used in regularization, and this distribution is also used in there is Gaussian naive Bayes, okay, naive Bayes method. Okay, so that means this is usually one of the familiar equation. For a standard normal distribution, that means we can say that complete normal distribution, you will get mean, median, mode equal, and it is symmetric about the center. So it means that the 50% values we will get in this side, and 50% values we will get this side. So we will have more generalized formula also. Uh, so now, how can we plot a normal distribution or Gaussian distribution? So if we know that sigma, if we define the S, and then for X, if we have X, maybe the data like 0 to 15. So we have this 0 to 15. For each and every X, we can determine the Y. That is the probability distribution. Okay. So if we get the X and Y, then if we plot, then we will get this kind of curve. This is actually our Gaussian distribution curve. So what we need to know, we need to know the there is mu, and also we need to know the sigma. Some other properties of our normal distribution is this. There is, we can see that if we consider one data is normal distributed, then we will get 68% of values within one standard deviation. So that means within this range, we will get within one standard deviation, the positive one and negative one. Total, we will get 68% of the values. And 95% of the values we will get within within two standard deviation, that is positive 2 and negative 2. So you can say 95%. And 99.7% of the data you will get within three standard deviations. Okay? Three standard deviations. So this is very nice properties of our normal distribution. We will see also more granular representation. Okay. Then what's the benefit of this normal distribution if we consider the sum data are just normally distributed? So like here, it is the information is given 95% of the students at a school are between 1.5 meter to 1.7 meter tall. So if we assume that the data is normally distributed, or you can say student heights are normally distributed, then what will be the mean value of the student heights, and what will be the standard deviation of the student heights? So that means based on just these three information, we can find out the mean, we can find out the standard deviation, though it is not mentioned here. So 95% of students at a school are between this and that. Okay, so we can see that actually for the 95%, here's the 95%, we have the 1.1 to 1.7, and we know that this 95% actually will reside within two standard deviations. So two standard deviations means, so two standard deviation means you can see two standard deviation. It means two positives, here is the two negatives. Okay, within this. So how many sigmas are there? 1, 2, 3, 4. That is 4 sigma. Here is the 1, 2, then 3, 4. Okay, 4 sigmas are there. Now, at first we can determine the mean. So mean will be, here is the 95%. So mean will be here. Mean will be here. Okay. So in this case, we can see that is 1.1 plus of 1.7, then divide by 2. So the mean here is, so mean here is 1.4. Now the standard deviation, if we want to find out the standard deviation, so in case of the standard deviation, it is like so standard deviation, the difference, okay, difference is 1.5 minus of 1 point. So here this is the difference, but actually we have 4 sigmas are there. So therefore we have to divide it by 4. Then we will get the sigma equal 0.15. So that means we can get the sigma that is our standard deviation is 0.15, and mu that is mu is 1.4 from this information. Okay, so we can easily get those information. Now we have to understand that is the standard score, or we can say Z score. In data science, in machine learning, you will see that one of the function usually for scaling, usually we use called the standardization. Okay, use the standard scalar. Then what does it mean? Actually, what it will do? We need the standardization because we want to convert our data of different dimensions to a fixed dimension. Like maybe we can say data one feature maybe from uh, 2 million to 2 million to minus 5 million, and another one is just 1 kilo to 5 kilo. But we want to standardize that so that there is each and every features we will get the fair weight. Okay, so for that usually we do a standardization or normalization. So what does it mean? Standardization means it is kind of G score. Okay, the G score. So we need to find out the G score and what is it. So for example, in the same school, one of your friend is just 1.85 meters tall. Then we can what's the G score for this? The G score usually we define the number of standard deviations from the mean. Okay, number of standard deviations from the mean. So now we can see that here is the height is 1.85. So 1.85. If we can see here, there is within the 95%. We can see the height here is 1.7, but for your friend it is 1.85. So that is more than that. So that means uh, the the student height, it will lies more than two standard deviations. But exactly what's the standard deviation for that? More than two, okay, we understand more than two, but what exactly what's the standard deviation for that? Okay, to find out the G score, uh, that is the equation is this: G score for a sample, it is the x minus of mu divided by sigma. So we already know the mu from our previous that is examples. From here we already determined the mu and standard deviation. So now we can just place that here is the mu and standard deviation. So mu is in our case 1.4 and standard deviation is 0.15, and x in our case x is the height of your friend. So height of your friend is 1.85. So it is x minus of mu divided by sigma, then we will get 3. It means that your friend's height is in 3 standard deviation. Okay, 3 standard deviations. So now if we have many values, okay, if we have many values, then we need to do the standardization. That means we need to perform the standardization using the equation of G score. Like here, this is normally distributed data. Then if we perform the standardization, then what we will get? We will get those data in our standard normal distribution. That is our standardization. That means each and every value, like here 1010, this is converted to 0, and then 990, this one is converted to -1, like this way. Okay, so that means how can we get those? We can get those using the Z score. So Z score is the number of standard deviation that value will reside. Okay, so how can we find out that? At first substitute the mean. So from that value, from any values, like here 950, here 950, from 950, we have to subtract the mean. At first this is our mean is mu, and then we have to divide by sigma. Okay, so then we will get this kind of values. Let's say we have a set of data, like here one example is this is travel time. Okay, we surveyed and also collected the travel time of each and every person, maybe from home to university. And some of the students mentioned that 26 minutes, and some of the students mentioned the 33 minutes and 50 minutes and 62 minutes, like this way. So now we want to normalize this score, or you can say standardize this score. Then how to do that? So that the rule is that at first we need to determine the mean. So from these values, the mean in this case is 38.8. And a standard deviation, we need to determine the standard deviation. Here the standard deviation is 11.4. And if we consider the population, then we have to apply this equation for a standard deviation. And sample, we have to use this equation for a standard deviation. Okay. So we know these things. Okay. Then what we have to do, then apply what we have to do at first from the value, the like 26. From 26, we have to subtract the mean. Mean is what? Mean is 38.8. So it is negative 2.8. Then we have to divide this one by standard deviation. Standard deviation is 11.4. So here is the 11.4. Then we will get this. This is our, there is the Z score or a standardized score of 26. So in this way, we can also determine the standardized score of other values like 33, 65. Okay, so 33 and 65, those values. So if we determine this, then we can see that these are the actually standardized scores. And on that case, we can see that previously we have 26. The 26 is now actually minus 1.2, 12, and 33 is now minus 0.51. So those are our standardized score. So usually we need to do a standardization for data pre-processing. Okay, data pre-processing. Many of us actually we utilize the standardization for scaling, but actually we don't know what's the inside. That is how we can do that. So now the next thing is what other use of the standard scores. So another use you can see here, that is one example. One of the professor maybe just conducted one exam, maybe quiz exam, and in that quiz, out of the six students got like 20, 15, 16, 32. Okay, then if you decide like this, that is the okay 50% is the pass marks, then we can see that most of the students will fail because the greater than 30 values is like just 2, 32 and 35. So most of the students will fail on that case. So that is not fair. So what we can do, so he can think about something that the relative, or you can say close, uh, so close relations. Then to find out the close relations, we what he can do, he can convert these values to a standardized score. So the standardized score is this. This is the standardized score using the Z score formula. Okay, so Z score formula. Now he can just say that okay, there is maybe the deviation is less than 1, or we can say less than minus 1, will be considered as the fail only. Okay, and others they have those values are closed, so we can say that okay, uh, we can pass them. Okay, we can pass them. So that means the standard deviation on that case, we can see that the standard deviation is less than 1. So you can see here this one is less than 1, this one is also less than 1. So in these two candidates will fail and others will pass on this case, and this is much fair to the students. Okay, instead of like saying the 50% will be the pass marks. So that's another use of our standard scores. Okay, so another thing we can also find out from our if we consider the normal distribution or the standard distribution. That is, if your score in recent test was like zero point 0.5 standard deviation, above the average, okay, above the average is 0.5 distribution, then how many people scored lower than you? Okay, we can also find out the the answer for this, that how many percentage, okay, nearly how many percentage of students scored lower than you. So we converted those scores, and now we can see that your score is here. There is 0.5, okay, 0.5. So here is the 0.5, and if this one, the marks is distributed following the Gaussian distribution or normal distribution, then we can see here this part, we will get the 50% students will be in this side, and 50% will be in this side. But you are here, that means you're 0.5. So 0.5 means we can say 19.1%. 1% will be within 0 to 0.5. So that means 50 plus 19.1, it is 50, 60, 69.1%. So that means 69.1%, 1% of students scored lower than you, okay, lower than you. So that's also interesting to find. So here is 69.1%. Okay, now for inferential statistics, we want to discuss about the hypothesis testing, okay? And from this lecture, we will continue maybe next 2 lectures on it. So hypothesis testing, what is hypothesis? Many of data science problems, you will find that you need to test the hypothesis, okay? Many data
Sir,
science applications. Huh.
sir, don't we have the previous part for mathematics in exam?
Yeah, of course we have.
Sir, it will be better if we can get one more example from the previous part.
One more example, what kind of example? Okay.
Sir, mathematical example.
I have already set many examples. Which one you want to actually study more? Which one you want to more example?
স্যার আই মেন্ট স্যার আমরা যে এখানে যে এই ফর্মুলা দিয়ে যে ম্যাথগুলো এখানে
হুম, হুম,
শিখেছি,
হুম, হুম,
তো
হুম,
স্যার
হুম।
এগুলো কি হচ্ছে এরকম ছোট ছোট ম্যাথ নাকি স্যার আগেরগুলোর মতো অনেক বড় বড়?
না, এটা ছোট ছোট ম্যাথ, কারণ এখানে তো খুব আহ, মানে আমরা শুধু ডিটারমাইন করতেছি যে জেড স্কোর কত হবে, ঠিক
ও
না? মানে
আচ্ছা আচ্ছা স্যার, একটার সাথে
পরীক্ষা,
একটা রিলেটেড।
হ্যাঁ হ্যাঁ হ্যাঁ,
ওকে স্যার, বুঝতে পেরেছি স্যার, সরি।
ইউজুয়ালি ডেটা সেট হয়তো দেয়া থাকবে, তোমাকে হয়তো মানে বলা হবে যে না তুমি স্ট্যান্ডার্ডাইজ করে দেখাও।
স্যার
তো
বুঝতে
সেটা,
পেরেছি স্যার, আই থট যে এতটুকুই।
আচ্ছা ওকে। Okay, so next topic is our hypothesis testing. So in hypothesis testing, what's the hypothesis testing actually? What does it mean by hypothesis? So the hypothesis usually we call it's an educated guess. If you guess something, uh, that's your hypothesis. Okay. You can guess anything, but that's the hypothesis. Uh, so we can say that a new medicine you think might work. So you invented a new medicine, and then maybe you thought that it will work perfectly. It will work perfectly. Okay. But on that case, what you have to do, that is, maybe you test that medicine to several people or several patients, and you get the good result. But still, it will not be acceptable for the community. That is, this new medicine will it will work fine. So what you have to do, you have to prepare the test several samples. That means you can say a standard number of samples you have to test that, and then based on the outcomes of the test, then your claim will be actually accepted or maybe rejected. So based on some sort of statistical inference method, okay, it's a statistical testing method. Now another thing, like a way of teaching you think might better, okay, so if you just thought it, So that's the hypothesis, your hypothesis. Maybe you can say that providing uh, recorded lectures will enhance or increase the score of students. You can think like this. This is maybe a better teaching method. But you have to test this one to several groups of students. And then you have to assess them maybe by using some form of test, assess their score, understanding a score. Or you can say at least you need to do some survey about their learning experience. So from that you can finally it can be accepted or maybe rejected, the hypothesis you mentioned. Okay. So hypothesis can be anything that you want to case. Usually we call it educated case. So educated case. Uh, so hypothesis, usually we have like different types of hypothesis. Sorry. Okay, so here is the hypothesis statement, some of the statements, hypothesis statements. The statements can be like, if I do this to an independent variable, then this will happen to the dependent variable. That means usually we have two parts in hypothesis. Or you can say if I give patients counseling in addition to medication, then their overall depression scale will decrease. So this is the hypothesis. That means here dependent and independent. Independent is given patient counseling in addition to medication, and dependent is the depression scale. Okay. So if I gave exam at noon instead of 7, then student test score will improve. This is hypothesis. Okay. If I look in a certain location, then maybe I am more likely to find new spaces. Okay. If I give like A plus to 98% of my students, then maybe I will get another sections in next semester. If I give A plus to 99% of my students, then there will be no excellent students in near future. Uh, uh, so that's the hypothesis. And if I make the question hard, then maybe I'm more likely to become famous. So all those are just a hypothesis. So to prove those things, uh, those hypotheses, you have to study those, collect the survey reports or maybe some form of testing reports you have to collect, and then you have to apply some statistical inference methods to test whether the hypothesis is true or false. Why it is important? Because we can see that there is sometimes we may get the results by chance. Okay, so if we test the hypothesis, then it will sure about that whether the result is just by chance or actually the data has this meaning. Okay, or you can say the data has this insight. uh, so that's why we have to test the hypothesis. Okay, so whether the data has any meaningful results, or we can say just we get that result by chance. Most of the cases we test our machine learning models and got the accuracy of like maybe 99%, 94%, 95%. But how many times you have tested that? And how many times you got the same result? Maybe you can say that just by chance you get the 99% one time. So that's the by chance, okay? That's by chance. That's not your actually reproducible research. So you cannot reproduce the same result again and again. So that's why we need to test the hypothesis, okay? And we need to define some other metrics, not only the accuracy, for claiming that the performance gain of your models. Uh, so the first we have to understand that there are two kinds of hypothesis. One we call is null hypothesis, and another one is called the alternate hypothesis. What is null hypothesis? Null hypothesis is always the accepted fact. There is we can say that everyone already know that fact. That is called the null hypothesis. Like DNA is shaped like a double helix. So this is the accepted fact. So this is called the null hypothesis. Okay. Um, then if someone say that there is maybe uh, for some Homo sapiens the the DNA is not like the double helix. So for claiming that or for proving that we have to test the null hypothesis. Okay, test the null hypothesis. And null hypothesis, it is usually we test the null hypothesis and it can be rejected or maybe accepted. So that's why usually we call null hypothesis nullifiable. That means something you can accept or maybe reject. Okay, so now the history is given like a researcher thinks that if knee surgery patient goes to physical therapy twice a week, so twice a week, currently they do that like thrice a week, okay, 3 times a week. The recovery period will be longer. So this is a hypothesis, okay, recovery period will be longer. So in this case, average recovery time of knee surgery patients currently it is 8.2 weeks. Then what will be our null hypothesis? In this case, uh, this is quantifiable. That means we can say the hypothesis here that are quantifiable. So we have the average, okay? And it is mentioned that it will be longer. It means that for the null hypothesis, usually we define null hypothesis using HO. It is called null hypothesis. The mean, you can see that this is the mean. The mean is average recovery time for knee surgery patient is it is less than, you can say it is less than or maybe equal 8.2. So this is our null hypothesis. But what will be our alternate hypothesis? In that case, the alternate hypothesis will be that means that we can see here that is a recovery period will be longer. That means the mu will be greater than 8.2. 8.2. So this is our null hypothesis and alternate hypothesis. From the data set, maybe collected data set, using the three times surgery, that is three times physical therapy. Finally, we can test using the inferential statistics and also mention that, okay, this is nullifiable or rejectable or acceptable. Okay. Uh, so we have already discussed this. Okay, I think we can actually stop our discussion today. In our next class, we will start from here. There is the example and from the given data set and how to test the hypothesis using some form of testing method. Okay, testing method. Okay, thanks everyone for joining this session. See you in your next class.
Okay, sir.
Thank
Thank
you,
you,
sir.
sir.
Assalamu alaikum.
Assalamu
Walaikum
alaikum,
salam.
sir.
All